chemical equation. Okay, let's get started. What is oxidation number? So basically, oxidation number is a number assigned to the atom according to some rules. So means here that each of your atom has their own oxidation number. So the oxidation number is used to identify elements that are oxidized or reduced. So oxidation number tu bagi tahu kita bahawa sama ada atom awak tu reduce or oxidize. So there are rules to assign oxidation number. So kita bukan main letak je nombor-nombor oxidation tu. Okay, ada dia punya peraturan. The first one, oxidation number for free or uncombined element is 0. Okay, ataupun oxidation number untuk atom lah. Okay, is 0. For example, sodium atom, oxidation number 0. Bromine molecule, okay, so bromine molecule, the oxidation number 0. Why? Because the element, walaupun atom dia ada dua, Br, but it consists of the same element. So basically, dia adalah, kita panggil uncombined element. So we have magnesium atom, we have chlorine molecule, oxygen molecule. So basically, if your atom is neutral and you have element, so the oxidation number is 0. Okay. Next, simple ion have oxidation number equals to their charge. For example, Na+. Okay, Na+, so the charge is positive 1, meaning that oxidation number dia positive 1. So chlorine minus, okay, because of the charge, the oxidation number is negative 1. O2 minus, okay, so since the charge is negative 2, so oxidation number dia negative 2. So H plus here, so basically the charge is, oxidation number is positive 1. So untuk ion, oxidation number bersamaan dengan dia punya charge. Okay, baiklah. Dekat sini, apa maksud charge tu? Okay, maksud charge tu, for example, sodium plus, magnesium 2 plus lah, sorry. Okay, so the oxidation number is positive 2. So maksudnya magnesium ni lose 2 electron in order to achieve stable octet configuration. Okay, so that is meant by the number. Okay, now I have a question here. What is the oxidation number for magnesium chloride? Okay, next. The third one. The sum of all oxidation number of all atoms equals to the charge of the entire species. For example, H2O. Okay, we have two elements, element hydrogen, element oxygen. So we know oxidation number for hydrogen is always positive 1. Okay, so since we have two oxygen, so times 2 lah. Okay, next. We have element oxygen. So we know oxygen is in group 16 in periodic table. So group 16 ni, dia perlukan 2 lagi elektron in order to achieve octet configuration. So what happened? The atom wants 2 more electron. Therefore, the charge is negative 2. So when you add these two numbers, so the charge, the answer is 0. So the number tells us that, okay, water is neutral. Okay, water is neutral. So maksudnya kat sini, when you add oxidation number for each of the element, and if your answer is 0, okay, means that your molecule is neutral. So samalah dengan HCl kat sini. So you have element H, the oxidation number is 1. Cl, the oxidation number is negative 1. Why? because Cl is in group 17. Mana pen? Okay, Cl is in group 17, so we know it needs one more electron to achieve stable octet configuration. Okay, so when you add these two together, so the total charge is 0. So maksudnya HCl is neutral. The same goes to KMnO4, MnO4. Okay, now we go to MnO4 minus. Okay, so the charge for potassium, since potassium is in group 1, so the charge is positive 1. The oxidation number is positive 1. Manganese, the oxidation number is positive 7. Means that here, for transition element, it needs to lose 7 electrons to achieve octet. Okay, now we have 4 oxygen. So, we know oxygen, Madam dah cakap tadi, oxidation number is negative 2, and you have to times by 4. So, when you add together, okay, the oxidation number is 0. Means that KMnO4 is neutral. Okay, now we look at the ion. Okay, for example, NO3 minus. Okay, let's continue for NO3 minus. So, first, minta padam yang Madam bagi dalam notes tu sebab dia tercopy paste dengan yang kat atas tu. Okay, so first, for NO3, for N, the oxidation number is positive 5. Means that nitrogen lose 5 electron to achieve stable octet configuration. For oxygen kita dah tahu negative 2. But because we have 3 oxygen, so times by 3. So when you add together, you will got negative 1. So the negative 1 corresponds to the charge of your species. Okay, so nampak tak? Untuk Cl2O7, okay, when you add all the oxidation number together, so you will get negative 2. So negative 2 inilah adalah the charge untuk keseluruhan species. Okay, that is the third one. Let's continue the fourth one. Fluorine and other halogens always have... Okay, baiklah. Let's have a look at the fourth one. Fluorine and other halogens always have oxidation number of negative 1. Positive number occurs only when halogen combine with oxygen. Okay, so for example, sodium fluoride. So fluorine in sodium fluoride, the charge is negative 1. Okay, the oxidation number is negative 1. Kenapa? Sebab fluorine needs one more electron to achieve stable octet configuration. So same goes to chlorine. Okay, now for when halogen combine with oxygen, okay, the oxidation number will become positive. So for example, Cl2O7. So we know that if we want to find out the oxidation number for chlorine, so we put unknown X. So since we have 2 chlorine, so put 2X. Kenapa? Sebab kita ada 2 chlorine. So plus oxidation number for oxygen is always negative 2. Since we have 7 oxygen, so times by 7 lah, equals to 0. Why 0? Because there is no charge yang diletakkan dekat atas tu. Maksudnya molekul tu ataupun compound tu adalah neutral. Okay, now solve the equation. So you should get X equals to positive 7. Okay, so take note lah. Kalau halogen combine dengan oxygen, so the oxidation number will become positive. Okay, so now let's do some example here. Determine the oxidation number for chlorine for chromium in Cr2O7 2 minus. So, cara kerja dia sama macam yang ni tadi. Can you find out the answer? Okay, baiklah. Proceed. Example 2. Assign the oxidation number for sulfur in SO4 2 minus. Okay, madam mula-mula tulis dulu SO4 2 minus. Okay, nak cari oxidation number for S kan? Highlight the S. So, that is your unknown X. Okay. So, since you have 4 oxygen, so times -2 with 4 equals to, okay, so since the charge of the species is -2, so equation is equals to -2. Now, solve X. Okay, proceed with example 3 now. Okay, assign the oxidation number for chromium, for uranium, and last one, carbon. Okay, good. So now, let's proceed. Now we are going to look at balancing redox in acidic solution. Okay, so there's a 7-step you need to follow, but don't worry. Once kita dah buat latihan, you guys akan lebih faham lah. Okay, for example, the first one. Balance the following redox equation. Okay, let's follow the guideline. First is separate into 2 half equation. Okay, half equation tu maksudnya satu oxidation equation, satu lagi reduction equation. So, now we take out the first equation. Iron 2 plus the pair is iron 3 plus. So first, keluarkan species iron. Okay. So pasangan dia mestilah elemen yang sama. So kalau iron dengan iron, janganlah iron ambil dengan magnesium. Manganis. Okay, tak ngam. So next equation, MnO4 minus with Mn2 plus. Okay, from the equation, kalau awak tengok, iron 2 plus, iron 3 plus, the oxidation number increase. So basically, this is oxidation. Automatically, another half equation becomes reduction. Okay, so settle the first one. Separate into 2 half equation. Now, step kedua. Balance all element except H and O. Balance all elements. So I will use different pen lah. Okay, now we have one iron. Settle. Don't look at the charge. Jangan tengok charge. Tengok element. Okay, now the next equation, Mn. Settle. Okay, so settle the second part. Next, we are going to balance oxygen by adding water. So sekarang baru kita boleh balance oxygen. So the first equation no oxygen, so you don't have to do anything. So for the second equation, since you have 4 oxygen, okay, so we are going to add water. So kita akan tambah water di sebelah kanan. So, you tak boleh tambah water sebelah kiri sebab nanti tak balance lah oksigen tu. Okay. So, dah letak sebelah kanan. Now, since sebelah kiri ada 4 oksigen, so we are going to add 4 water. Okay, so that is the third step. Okay, step number 4. If you notice, when you add water, actually you are adding hydrogen as well. Tapi sebelah kanan, sebelah kiri, tak ada hydrogen kan? So we are going to add hydrogen. Okay, we are going to balance hydrogen by adding H+. So we are going to add H+. How much? Since we have 8 hydrogen over there, so H+ is 8. Okay, so that is the fourth step. Okay, number 4. Dah settle. So we are going to balance charge. Okay, now I'm going to write down new one. Okay. Salin je balik actually. Cuma tinggalkan sedikit ruang. Why? Because we are going to add electron now. Okay. Okay, back to the business. Balance charge. Okay. Kita akan balance charge by adding electron to more positive side. Okay, macam mana kita nak tahu positive side, negative side? Okay, let's have a look at the first one. Iron 2 plus and iron 3 plus. For iron 2 plus, the charge is positive 2. Iron 3 plus, charge is positive 3. So, maksudnya, positive 3 is more positive compared to positive 2. So, kita akan tambah elektron sebelah kanan. Sebelah kiri lah. Kenapa kita tambah sebelah kiri? Sebab sebelah kanan. Sebab sebelah kanan ni dia lebih positif. Okay, so how much electron kita nak tambah? Kita tambah 1. Kenapa 1? 1 electron, the charge is negative 1. Okay, so positive 3, negative 1. So the total will become positive 2. Okay, kita nak charge kiri dan kanan sama. Okay, let's look at the second equation. Okay, the charge for MnO4- is negative 1. Okay, untuk H+, the charge is positive 1. Tapi sebab ada 8, so darab 8. Mn2+, positive 2. Water, neutral, so 0. So when you add all the charge together, so on your left side, the total charge is positive 7. On your right hand side, the total charge is positive 2. So on your left is more positive. So we are going to add electron. How much electron? Kita akan tambah 5 elektron. Kenapa? Sebab 7 tambah 5 elektron nanti, balance nanti akan jadi 2. So, kiri dan kanan jadi balance. Okay, now. Okay, sambung balik equation tadi. Kita tulis cantik-cantik sikit. Okay. Last one, we are going to balance electron in the 2-half reaction. Okay. Sekarang kita akan balance electron. So, nak balance electron, senang saja. So, the first equation, you have 1 electron. Second equation, you have 5. So, the first one, everything will be times by 5. Okay, so now. So you will have 5 Fe2 plus. Okay. Fe3 plus 5 plus 5 electron. Okay, for the second equation, don't need to do anything because the electron is already 5. Okay, so we can cancel out the electron. Why? Sebab if you notice this one, electron sebelah kanan. This one, electron sebelah kiri. Always remember this rule. Kiri dan kanan, you guys boleh potong. Macam tolak. Okay. So now we are going to add all of them together. Cari pen. Okay. Yang berada di sebelah kiri, kita akan tambah. So 5Fe2 plus MnO4 minus plus 8H plus equals to 5Fe3 plus Mn2 plus 4H2O. So maksudnya kat sini, kita tambah semua yang ada dekat sebelah kanan. Okay. So sebelah kiri pun buat benda yang sama. So basically, this is your redox equation. Sepatutnya redox ni ditulis dalam satu straight line. 4H2O. Okay, so this is your final answer. Agak panjang, but if you follow all the step, you will be fine. Okay. Next, try to do on your own. This one. Madam bagi tips kat sini. Okay, you can ignore H plus and water. Okay, please ignore H plus and water. And you can refer to this one. Okay, refer to this step in order to answer the next